Now that we understand the math behind dividing complex numbers, we're going to try and solve a few problems from the SAT quickly and in our head. So let's just give the first question a read. You can see this is from the official practice test from the College Board, test number 2. Which of the following complex numbers is equivalent to 3 minus 5i over 8 plus 2i? So we just have to divide these two complex numbers. And so in the quick version of solving this, you shall need to first figure out the denominator in your head. And obviously we know that this would be in the form a squared minus b squared, because we have an a plus b here, and when we multiply it with the complex conjugate, it's going to become an a squared minus b squared, where a here is our 8, so 8 squared, minus our b is a 2i squared. And so we can just evaluate this. But the thing to notice here is that you have an I inside the second term. And what this I does is when you square the I, you get an I squared equals a -1. And what this means is this is always going to flip the sign, to change this sign that's in the middle, the sign which is a negative. And it will always become a positive. Even if you have a negative sign here, even if I had a -2 here, that negative would just become a +1 when you squared it. And so the quickest way to get to the denominator is to just take these two numbers, whatever they are, 8 and a 2, and square them and then add them together. So you need to add their squares together. So the square of 8, I would do in my head, 8 square is a 64, and then 2 square is a 4. So I would add the 2 and I would get 68. That's my denominator. Now for the numerator, well, we just need to multiply two complex numbers. Which two complex numbers? 3 minus 5i and the conjugate of 8 plus 2i, which is 8 minus 2i. And we've learned the quick way to doing that. You first take the real part of the first complex number, multiply it with the real of the second, you get a 24. You add that, you take the imaginary part of the first one and the imaginary of the second one, and that's going to be a -5 times a -2 is going to be a 10, and then an I squared is going to be a -1. So that's going to be a -10. So from here I got a -10, from here I got a 24, and this is doable inside my head. So I'm going to get 24 minus 10, that's going to be a 14 as my real part. And then let me do the imaginary part in a different color. So for the imaginary part, you're going to take the real part of the first complex number and you're going to multiply it with the imaginary part of the second complex number. That's going to be 3 times a -2, that's going to be a -6i, and then the imaginary of the first times the real of the second, that's going to give me a -40i. And this one also is obviously going to be inside my head. I'm going to see this gives me a -6, and I'm going to look at this, and this is going to give me a -40, and in my head I'm going to add them together. That's going to give me a -46i. And obviously you can write the numerator and the denominator if you want to, but the calculation part can be done inside your head. And so when I divide this by a 68, actually let me erase this. Yes, when I divide it by a 68, well, I can simplify this further because all of these numbers are divisible by 2. And so when I divide by 2 in both the numerator and denominator, I get a 7. Then a 46 divided by 2 is a 23 divided by 34. And as you can clearly see, the correct option is going to be C, because when I can clearly, just separate these two numbers. It's going to be a 7 over 34 minus a 23 over 34i. So that's how you get to the answer quickly. And so for the second question, let me scroll down to the second one. And I want you to pause the video and give this one a go yourself. Okay, so now let's just give it a read. If the expression above was rewritten in the form a plus bi, where a and b are real numbers, what is the value of a? So essentially what the question is saying is we need to divide these two complex numbers, and when we divide them we get another complex number in the form a plus bi, and what they're interested in is the value of a, or the real part of this complex number. So just as we did with the previous example, we're first going to figure out the denominator. And to do that, we're going to take the first number and we're going to square it. So 3 squared is a 9 in my head. And then we're going to add it to the square of the second number, which is the coefficient of I. And that's a 4. And so it's going to be a 3 squared plus a 4, or a 9 plus 4, which is 13. That's my denominator. And then for the numerator, we're only interested in the real part. So what we're going to do is, well, 8 plus I times the conjugate of the denominator, which is going to be 3 plus 2i. And now to get to the real part, we have to multiply the real part of the first with the real of the second, and the imaginary part of the first one with the imaginary of the second, and add them together. So the real and the real gives me 8 times 3, a 24 in my head. And then, sorry, this is not a positive, this is a negative. What am I doing? So a negative I times a plus 2i, that's going to be a negative 2i squared. And an I squared is a negative 1. So that's just going to make this positive. So 24 plus 2 is a 26. Is it? Yes. And so I'll have a 26 divided by 13, which is a 2. There you go. A is your answer.